So you've got this brilliant AI that knows a little bit about pretty much everything. But how do you take that general knowledge and turn it into a world-class expert in something specific, like medicine or finance? Well, that's the magic trick we're going to break down in this explainer on LLM fine-tuning. Here's what we're going to cover. First, we'll look at why we even need to go from a generalist to a specialist. Then we'll walk through the actual pipeline for doing it. After that, we'll dive into a really smart way to tune that's all about efficiency. We'll also compare fine-tuning to another popular method called RAG. And finally, we'll take a quick peek into the future. All right, let's dive right in. The big question is, why bother? Why do we need to take this AI that already knows so much and give it this specialized training? Okay, so picture this. A base large language model is kind of like a genius who just graduated from a top university. It has this huge amount of general knowledge. Fine-tuning? That's its specialized, on-the-job training. We take that powerful pre-trained model and just continue its education, but this time on a much smaller, super specific data set to turn it into an expert. And this table, man, it lays it all out perfectly. It really shows you the two big phases of an LLM's life. You see, pre-training is that crazy expensive university phase. It's a massive, massive undertaking using data from all over the internet to build that broad knowledge. Fine-tuning, on the other hand, is the much quicker, much cheaper specialization phase. It uses a focused data set to adapt all that general knowledge for one specific job. So, how do you actually build one of these specialist AIs? Well, it's not as simple as just flipping a switch. There's a whole process, a full-on assembly line, really. And that's the fine-tuning pipeline. Yeah, you're not just hitting a train button here. This is a complete production line. It covers the whole shebang, from getting all your data ready and setting up the model to the actual fine-tuning and testing, and then finally, getting it out into the real world and making sure it keeps working right. Look, all 7 of those stages are important, for sure. But if you want to get to the real heart of it, it pretty much boils down to these 3 critical phases. First, you've got data preparation. That's like gathering the perfect set of textbooks for your new specialist. Second is the fine-tuning itself. That's the intense all-night study session. And third, evaluation. That's the final exam to make sure it actually learned what you needed it to. But there's a catch. That intensive study session we just talked about, it can be wildly expensive. And that huge problem, well, it actually led to a pretty awesome breakthrough in efficiency. It's all about working smarter, not harder. To really get why this is such a big deal, you have to think about the scale. Full fine-tuning means you have to update every single one of the model's parameters, and we're talking about hundreds of billions of them. This requires a staggering amount of computer power, just an insane amount of memory. For a lot of people, that's just completely off the table. So what's the solution? It's this incredibly clever set of techniques called parameter-efficient fine-tuning, or PEFT for short. Instead of wastefully retraining the entire model, PEFT methods find these really smart ways to get the same results by only updating a tiny, tiny fraction of the model's parameters. It's a total game changer for cost and resources. And probably the most famous of these PFD methods is one called LoRA, or low-rank adaptation. The idea is just so smart. What LoRA does is it freezes all of the original model's weights, doesn't touch them. Then it injects these teeny tiny trainable adapter matrices into the model. So all the new learning happens only in these little adapters, not the whole brain. It's brilliant. And here you can just see the difference. On the left, full fine-tuning is this massive, clunky operation. But look on the right. With LoRA, you only have to train those 2 tiny little adapter matrices, A and B. The number of parameters you have to train just nosedives, but the performance, it stays remarkably high. Okay, so now that we know we can fine-tune things way more efficiently, it brings up a really important question. Should you even be fine-tuning in the first place? It's all about choosing the right tool for the job, and that means comparing it to another major player on the field, RAG. Yeah, this gets to a super practical question that any developer has to ask themselves. Is fine-tuning always the answer, or is there another way that might actually be better? The key here is to understand their different jobs. You fine-tune when you want to change the model's fundamental behavior or its style, like you want to teach it a new skill, like how to write code, or maybe give it a specific persona. But if all you need is for the model to access new information, like answering questions from your company's internal documents, then retrieval augmented generation, or RAG, is often a much better and simpler choice.
RAG doesn't change the model. It just gives it the right book to read from at the right time.
So let's wrap up by looking ahead. Where is all of this headed? What does the future of AI specialization even look like?
Even with all these amazing breakthroughs, there's still some really big hurdles to clear. We're still grappling with the immense cost and scale of these models. We're working on how to make sure these specialized AIs are fair and unbiased, and we're trying to make their decisions transparent enough so we can actually hold them accountable.
But this is where it gets really exciting. Fine-tuning isn't just about words anymore. We're moving fast into a world of multimodal models, AIs that can understand images, sound, and video. We're on the verge of creating specialists that can literally see and hear. And that really brings us to the final thought for this explainer. The technology to create these highly focused specialist AIs is becoming more powerful and more accessible every single day. So the question we're all left with is no longer just, can we teach them? But as this power grows, how do we make absolutely sure we're teaching them the right things?